Right, hello Year 7. I hope you enjoy this video on corrections. Just a reminder, if there's a question you got right, um, if you don't want to hear it, just skip forward. If you've got all the questions right, there's a file with extra questions for you to try for homework. But even if you haven't got any right, it's okay, we're going to go through it. When you're finished, have a go at those questions as well. Just a quick note as well, anything I write, or any way I write, I need you to do the same thing, because this is the correct way of writing, it's the best way of writing, so you can see your information and see how you would write as well. Okay, let's start. Question 1. Ben, Tom and Adam each buy different coloured yo-yos. One yo-yo is red, one is yellow and the other is green. Use these clues to complete the logic table. So the first clue we're given, Ben's yo-yo is not green. So it could be any other colour, but it's not green, so we're just going to put a cross in there. Tom's yo-yo is not red or green. So Tom's yo-yo is not red and it's not green. And the only box or any colour that is available is for it to be, not red, it's not green. The only box for it to be available is yellow. Since there is only one colour left for green for Adam, Adam must have the green yo-yo. And if Adam and Tom have the yellow and green, the only colour left, the only colour yo-yo left is red, which is for Tom. Sorry, for Ben. Okay. We can put a cross in these boxes and done. So, state the colour of the yo-yo each boy buys. So, you have to state this. This is part B. So for part B, you have to say Ben has red yo-yo. Adam has a green yo-yo. And the last one, Tom. Tom has the yellow yo-yo. When it says state in a question, you have to do some writing and you have to describe what you found out. And that is done. Question 2. In a survey, people were asked if they owned a car and if they owned a bicycle. The results are given in the table below. So question A, how many people owned a car and a bicycle? So the people that owned a car and a bicycle is in this box, just like coordinates. This 28 is related to the bicycle and this 28 is related to the car. So car and bicycle is 28 people. So 28 people. For B, how many people owned a car but not a bicycle? So this number here represents a car and no bicycle. So that's 30 people. Part C, how many people each owned a car? Well, 28 people owned a car and a bicycle, or 28 people owned a car and a bicycle, and 30 people owned a car but no bicycle. So altogether, the people that owned a car was 28 and 30, which is 58 people. And D, how many people each owned a bicycle? Now, how many people each owned a bicycle? Let's take a look at the table. This row represents everyone that owns a bicycle. 28 people owned a car and a bicycle, and 5 people owned a bicycle and no car. So we do 28 plus 5, which equals 33 people. And E, how many people took part in the survey? Well, we need to add every number up because there was 28 people with a bicycle and car, 5 people with bicycle, no car, 30 people with no bicycle but a car, and 4 people with no bicycle and no car. So we have to add all those numbers up for the total. And if you add this up, so 28 plus 5 is 33, 33 plus 30 is 63, 63 plus 4 is 67 people. So the survey, 67 people took part in the survey. Question 3, copy and complete the Venn diagram. So just a quick copy, remember, doesn't have to be a neat copy, but remember to use your pencil and ruler. So here's my copy of the Venn diagram. And this is A and this is B. Now we're told a few things about this Venn diagram. A has sets 4, 7, 8, 9. B has the numbers 1, 2, 3 and 4. And we need to include all the numbers from 1 to 9. So remember, if we're going to include all the numbers 1 to 9, write them down. 1, 2, 3, 4, 5, 6, 7, 8 and 9. Now we need to see which is common from set A and set B. The only thing in common I see is 4, so 4 will go right in the middle. What we left in for A, we left with 7, 8, 9, so 7, 8, 9. For B, it's 1, 2, 3. And just quickly to take a look at the universal set. We have 1, we have 2, we have 3, we have 4 in the set. We have 7, we have 8, we have 9. You can tell from A and B, we've already written them down. The only numbers we haven't written down is 5 and 6. They don't belong to any set A or B, so we put them outside to the universal set. So this is part A. Part B is asking us, what is the intersection? Now remember the word intersection, I'm going to highlight in blue. The word intersection is what's in the middle of A and B, and the number you see in the middle of A and B is just 4 as a set. For C, what's the union of A and B? Now the union, I'm going to do it orange. Whoops. So the word union means everything inside A and B, so all of those, including the intersection here, and those numbers are 1, 2, 3, 4, 7, 8, 9. 1, 2, 3, 4, 7, 8, 9, and that is our set. Part D, what is the complement of A? So the complement of A is everything outside of A, and I'm going to do this in yellow. So complement of A, everything outside of A. So here's our A, including this part of the circle. So this, all of this circle is our A, and everything outside of A is the complement of A. So I'm just going to shade in everything so you can clearly see which numbers are the complement of A. And the numbers are, well, 4 is inside A, so that's not the complement of A. 1, 2, 3, 5, and 6. 1, 2, 3, 5, and 6. Don't forget these ones, these are outside of A as well. Okay, question 4. In a class of 29 children, each child plays at least one sport. 20 children play football and 18 play cricket. How many children play cricket and football? Now the problem is, if we add these numbers up, which some students would do, 20 children play football and 18 play cricket. If we add them up, we get 38. Now that's not going to be the right answer because we have only got 29 children. The problem is when we add these up, we are going to get a couple of things or a couple of children that we've counted twice. So when we do 20 plus 18, which equals 38, we have to do 38, take away that 29 children, and that gives us 18. 18, yes it is. And if we do 18 divided by 2, we get 9. And this 9 is the number of children, so number of children play football and cricket. The way this works, or the way this method works, if you'd like to know, is as follows. We have space for 29 children. So imagine this as your classroom as 29 children over here. So this is our classroom of 29 children. Now, I'm going to highlight 20 children that play football. Let me just highlight it properly. So 20 children play football and 18 that play cricket. Then we can start counting the number of children. So here's the 20 that play football. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And children that play cricket would be, well, we need to add another 18. So far we've got 20, 21, 2, 3, 4, 5, 26, 27, 28, 29. Then we can't add one more child because we've only got 29 children in the classroom. So the rest of that 18 must be part of this purple, or the part of students that play football. So far we've got 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So we've got that 38 sports that we've got over here. And these students are the ones that play football and cricket. How many do we have that play football and cricket? 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you would get the number of children that play football and cricket. The maths that you would do, you would add them up. So you do 20 plus 18, you can see here it's 38. 38 take away the class to give us 18. Now we have to divide that by 2 because there's 2 sports that one child plays, and that's 9. So 9 children play football and cricket. Question 5. The set S represent the number of members of squash club, and the set T represents the number of members of tennis club. Make 2 copies of this Venn diagram. So, and on one diagram, shade the region, shaded the part that represents the people who are members of both clubs, and part B is on the other diagram, shade the part that represents the people who belong to the squash club but not to the tennis club. So the first thing they tell us to do is make the Venn diagram. So I'm going to copy down the Venn diagram. So here's the first one, the first circle. Here's the second circle. We'll make it look. Okay, and here's S, here's T, and here's a universal set. So make 2 copies. I'm going to make 2 copies of this Venn diagram. So here's the first copy and here's the second copy. And it's saying for us on one diagram, the shaded part that represents the people who are a member of both clubs. Well, this region would represent people who are in the squash club and tennis club, because if we were to put it here, it would be only in squash. If we put it here, it would be only in tennis. But over here, in this region, it would be in squash and tennis. So that's part A. And for part B, I've been a bit naughty. I've written on the right hand side. I need to bring it down. It's part B. And for part B, it says, on either diagram, shade the part that represents the people who belong to the squash club, but not the tennis club. Well, in this region, obviously, I'll be in the tennis club, so it's not in this region here, anything in that region. In this region, the intersection, I'll be in the squash and tennis, but that's not what we're looking for. We want just the squash club. But in this region, we'd only be in the squash club. In fact, this is what I could do. So that would be the only region would be in the squash club. I hope this was helpful. If you have any questions, you can come and see me again. And the questions that I would like you to do are questions 3 and questions 4. I will put them in and show my homework. Let's just take a look at what they're asking us to do. The whole numbers from 1 to 12 are included in the Venn diagram. Draw the Venn diagram, sets A and B. What is the union of A and B? What is the intersection of A and B? What is the complement of A and B? It's very similar to question 3 that we did. Okay, and question 4. In a class of 32 children, there are 8 children who belong to no club at all, 16 who belong to the music club, and 5 who belong to both music club and chess club. How many children belong to the chess club? This, you would need to draw a Venn diagram for with how many do we need in the class? There are children who belong to no club at all, 18 who belong to the music club, and 5 belong to both music club and chess club. So our Venn diagram will look very similar to this that I'm going to draw. It's a very bad Venn diagram. I'll just draw a little bit of an oval so we can fit it in. So here's the start to the question. So here's the music club and here's the chess club, C for chess. Remember, fill in what's in the middle and then try to work out how many people belong to the music and how many people belong to the club, and remember to fill in to no club as well. So no club at all would be 8 children who don't belong to a club at all. So try to fill this Venn diagram in and work out how many children belong to the chess club, and the chess club would be this region here. Okay, hope this was helpful. Like I said, any questions, come and see me.